Hello student, welcome to our physics discussion, that is continuing discussion, and that is your physics in a smart way. Okay, so we are involved with the so-called Maxwell equation, and our basic job was to establish Maxwell equation, or basically, to be very frank, to be simple, whether a student at class 12 or class 13 level, whether he or she will be able to understand it or not. Okay, using, you may say, without using difficult mathematics and all those things. And that too, we are also prepared to share SHED to remove the unnecessary physics, especially the so-called variance, the so-called variable quantities which are fluctuating. And at the same time, we consider, if we are considering electric field, we assume that electric field is only there. If we consider a magnetic field, we assume that only magnetic field is there. So thereby our equation, our treatment will look simpler. And our basic job was, as I told you before, to see whether you'll be able to understand it not easily. Okay. So if we, the so-called our planning, it was in the last class or in the last video that we are prepared to drop the unnecessary physics. So if I am to drop unnecessary physics from these equations, then you know the first equation that we have written here is nothing but the Gauss law. The closed surface integration of E dot dA. dA means area. dA means area, surface area, will be equal to enclosed charge by epsilon. If I remove this on the right hand side and speak mathematically, only mathematically, then this equation becomes that integration of dA is a quantity we at present don't recognize that enclosed charge and all that, because we are not physics student. We don't recognize we don't know what a charge is. We can say that is non-zero. Integration ADA equal to non-zero. That non-zero may be equal to a dog or a cat or enclosed charge by epsilon or whatever it is. We simply forget that. Similarly, if you go to the third equation, that is the integration of dl is d phi by dt. If magnetic field is not changing, then here d phi is the variation of magnetic field. Then we can simplify this equation in a not changing magnetic field, this equation to be zero. And the last equation, that is another well-known equation. It appears in electromagnetics, that is Ampere's equation. Ampere, you must have remembered him, is the cousin of Gauss and all those things. That is performed. And just like Gauss law, his equation is there in electromagnetism, which says the closed path integration of the so-called magnetic induction will be equal to mu into sigma I. But if I drop the physics portion of that, I don't recognize the current, I don't recognize the mu or the so-called permittivity, the permeability. We may say that this is a quantity which you do not know, neither we are interested in. So integration BDL is not equal to zero. It may be a quantity which has got serious importance in physics, but from mathematical point of view, just ignore it. So these are modified forms of the so-called and for us simplified and for us bit simplified, because we are prepared to drop physics from unnecessary physics from that. So let us say we consider the electric field. We got a point charge. Let us come down to the figure. We got a point charge. The point charge is there. The point charge is plus Q. The point charge electric field, we do know it creates, if the charge is positive, that creates a diverging type of field. The field radiates outwards and all those things. We consider a path which is a circular path. We consider a circular path around centering the charge, and we have considered a particular element dl on the path. Some people may say dl or ds, displacement or whatever it is. Those they mean similar. So we consider a small displacement on the path anywhere. I have shown you here. You may also see here. DL is a small displacement, has got a direction that is towards right. You may also take towards left. That depends on the way you want to move. So electric field is shown. Electric field is radiated outwards. So if I consider the quantity that in closed path integration of electric field and the closed path integration of the dot product of electric field and the displacement of the path will be equal to, we do know, this will be giving us nothing but the closed path integration. We shall be coming to closed path and all those things. Because you are involved with a dot product, that is E into dl magnitude into cos of angle between them. And as you can clearly see, because E is radial and dl is tangential, every time we are bound to see a 90-degree between them. And cos 90, obviously, we see it is 0. So for this element, we got E dl cos 90 equal to 0. For the next element, also the same thing happens because angle between E and dl is 0. And here we got a closed path integration. That means we consider all those EDLs, dot product of EDLs. That means EDL cos 90, and start from this point and also end at this point, dividing the path into a large number of small paths. That is the way of integration, as you do know. And you know the result will be equal to, nothing but equal to 0. Because every element you consider, every DL you consider on this path will be having E perpendicular. Now, the question is, if our path is circular and the circle centers the path and the charge centers the path, the charge remains at the center of the imaginary path that you have considered, then that is equal to 0. And we can see that is there as equation number 3 of the Maxwell equation. The thing that we have done, that is closed path integration or the circular integration of E dot dl equal to 0, we can see that is appearing as the equation number 3 of Maxwell. So thinking about Maxwell equation is not so difficult at all. But thing is that Maxwell will start to laugh and then throw in a challenge that, okay, guys, you got a very simple path. Your teacher did give you a very simple path that was a circle, and the point charge, the creator of electric field, was at the center of the circle. But will it be valid if the path is not a circle? Let us say we go for that. We go for those paths, and we try to see whether that is universally correct or not, whether that equation or that conclusion is universally coming correct or not. Okay, I need to take a pause. You won't be able to notice it. Okay, so I have drawn the path. The path that I have drawn, last path was a circle. Here, it's a closed path. The path must be closed because all our integration are closed integrations. The starting point and finishing point, they must be same. Starting position, finishing position, they are same. But deliberately, we have taken a bit odd-shaped path, which is never a circle. And let us say we are going to we are going to deduce, of course, not by any mathematical derivation, but mentally deduced, mentally imagine whether this will giving the same result or not. We do know, so far as the integration or the closed path integration of either DL is concerned, that means if I am starting from this, everywhere I go for taking in DL till the time the entire path is exhausted and I come back to the starting point and find out all possible pairs of E and DL and then make the dot product of E and corresponding DL, that is DL cos theta, and then add all those things, and a trillion of addition has to be made because it's integration, and because DL is a very small displacement, we know we have to make allowance for a lot of DLs. Okay, but we are thinking it, we are theoretically analyzing it, we don't have to do it practically. We can clearly see with a bit of thought, if you throw everything away from your mind, have a clear idea, have a clear conscience, and make your mind free, you can clearly see that if you consider a bit odd type of path or irregular path, there can be some DLs where the angle between E and DL is acute angle. And you know, when theta is less than 90 degree, when theta is less than 90 degree, cos theta will be coming out positive. In some cases, you'll be seeing also where theta is more than 90 degree. More than 90 degree means an obtuse angle. And everybody knows that cos theta or cos more than 90 degree is, or cos of an obtuse angle is negative. So thereby our common sense says, because it's a closed path, you start from any point, you take any direction, go clockwise or anti-clockwise. A lot of addition you have to do theoretically, but some EDLs will be positive, some EDLs will be negative, and they'll be cancelling out, the result will be still zero. Did you get me or not? If not done, or if you have not realized, then think about that, close your eyes, think about it seriously, because the starting point and finishing point, they are same. If I am going upward, then I have to go downward because my starting and finishing point is same. So thereby, a lot of cos thetas will be getting as positive, a lot of cos thetas will be getting a negative, and at the end, everything will be cancelling out. So thereby, that gives us an idea, that gives a feeling that this thing is an universal idea, not a particular singular idea, that integration of closed path integration of PDL will be equal to 0. That is in conversant with the law of conservation of energy. We know in a closed path, the sum total of potential gain or losses must be 0. And this DL is nothing but gain or loss of potential. So anyway, so if you are convinced now, we have established one of the so-called Maxwell equation, that is number 3, using our simple logic. Next class, we'll be going for other equations. Thank you. We shall be doing that in our next video.